In this video, I'm going to be showing you how to solve rational equations. We actually have already spent some time solving rational equations, but just basic types. I did that in a video where I said using the CSI 1 and 2 step to solve equations that have fractions in them. So you may want to watch that video first if you haven't already. So let's go ahead and get started. So first of all, a rational equation is basically just an equation that has fractions in it, or we call them rational expressions. So here are some examples. Let's go ahead and get started. So it says, well, first of all, we need to talk about how to find LCMs, because we're going to need this skill when we're doing these problems. So first of all, it says to find the least common multiple for two algebraic expressions. We're going to do the following. First, we're going to find the LCM of the numbers, and then we'll identify any algebraic factors. The actual LCM will be the LCM of the numbers times each algebraic factor that we find. So let's see how this works. First of all, we're going to practice finding least common multiples. So if you look at number 1, let's see, the multiples of 4 are 4, 8, 12, and so on. The multiples of 8 would be 8, 16, and so on. Notice that 8 is the smallest that they have in common, and so that's going to be our LCM. Oops, let me fix this real quick. Alright, let's move on to the next problem. Oops, and I already gave you the answer. It's 20 here. If you look at the multiples of 4 and you look at the multiples of 5, so we can do that. So 4, 8, 12, 16, 20, 24, multiples of 5, 5, 10, 15, 20. You can see 20 is the first one that they have in common. Now, we actually have a shorter way to do this. The way I like to do it, let me go ahead and start over here, is let's just look at the multiples of the bigger number, which is 5. So 5, first of all, 5 is not divisible by 4, so we'll move on. Neither is 10. 15 is not divisible by 4. Finally, we get to 20, which is divisible by 4, which means it's a multiple of 4, and it's also a multiple of 5. And so that's going to be my LCM. So basically, just start with the bigger number and look at its multiples until you find one that you can divide by the other number or the other numbers. All right, so let's look at number 3. Let me erase these here. So this time we're looking at 4, the biggest number there, and 4 is not divisible by 3, so we got to keep going. Still have the same problem, 8's divisible by 2, but not the 3. But 12 does work. 12 is divisible by 2 and 3. That's going to be our LCM. All right, if you look at number 4, we don't have but one numerical factor, the 3, and we have one algebraic factor, so we just need to multiply the two together. So our LCM here would be 3x. If you look at number 5, for 4 and 8, the LCM of 4 and 8 would be 8. Notice 8 is divisible by 4. And we also need to include the x factor, so 8x is your LCM. So you might want to stop the video and see if you can do number 6. Alright, so 18 is divisible, 18 is my biggest number, and it's divisible by the other 3. So that is my LCM, but I also have an x factor I need to include. It's an algebraic factor, so 18x is our LCM. Now when you get to number 7, x and x plus 3 are considered to be different numbers. It's not like if I had 3 times x, then I would include a 3 and an x. We have to treat these as totally separate factors. So we would do this by multiplying the two together, and x times x plus 3 is going to be our LCM. Similarly, on number 8, we just multiply the two factors together. There's nothing more we can do. All right, so let's move on. So now, from the last video we looked at, where we talked about equations that have fractions in them, we learned that to clear fractions, we have to multiply both sides of the equation by the LCM. Basically, each term gets multiplied by the LCM. In this case, we have two terms on the left and one on the right. So here our LCM, well, we only have one denominator. It's going to be x. Now, when we're working with fractions, we call these LCDs. So it's really just the LCM of the denominators. Here we only have one denominator. That's our LCD. So let's multiply each of our terms by x. We're going to get 8x plus, notice our x's cancel. We get 10. And on the other side, we're going to get negative 2x. So again, we talked about CSI before. We just cleared the fractions. Now we're going to simplify. S is for simplify. There's nothing on either side you can simplify, so that's done. I is for isolate. Do we have x on one side only? We don't, so we need to get it on one side only. So we could get rid of the minus 2x there, but I really don't want to get 0 there. So let's go ahead and subtract 8x on both sides. And we're going to end up with 10 equals negative 10x. And divide each side by negative 10, we're going to get negative 1. All right, let's look at another one. So here our only denominator is x minus 1. That's going to be our LCD. So let's multiply each side by x minus 1. So on the left, the x minus 1's cancel. You're left with x plus 3. On the right, the x minus 1's cancel. You're left with 4. Let's go ahead and subtract 3 on both sides. We're going to get x is equal to 1. Unfortunately, we have a problem here that we haven't discussed up to this point. Let's look at the original equation. And notice what happens if I plug 1 in for x. Look at those denominators. This is something that should trouble you a bit, because 1 minus 1 is 0, and we know in a fraction we can never have 0 in the denominator. It makes us undefined. And so we did everything right. We got this answer of 1, but when you plug it in, it actually doesn't work. So this value 1 is what we call a restricted value. And normally we'll look to see what our restricted values are at the beginning, so that when we get to our answer we can double check and make sure that we haven't found a restricted value. If it is a restricted value and that's our only answer, then we'll have to throw it out. In this case, we have no solution. Another way to say that is we could say our solution is the empty set. There is no solution. So either of these will work, no solution, or you can write the empty set notation. All right, so here's the steps that we're going to use when we solve rational equations. It says list any restrictions, find the LCD of the denominators. And really, 1 and 2, doesn't really matter which order you do those in. I actually usually find my LCD first. And then we clear fractions by multiplying each side of the equation by the LCD, which we've been doing. We solve the resulting equation. And we just have to remember at the end to discard any restricted values. And we can always check our answers. Just be careful, because when you're working with fractions, sometimes the checking can be as hard as the original, solving the equation. All right, so let's look at some more examples. So let's find our LCD. We only have one number, it's 3, and we have one algebraic factor, x. So our LCD is 3x. Notice our restricted value here, x can't be 0. 5 over 0, that would make us undefined. Same if you had 6 over 0. So that's our restricted value. Let's go ahead and multiply all our terms on each side by 3x. So notice 3x times 5 over x, the x's will cancel, and you're left with 3 times 5, which is 15. Then we have a minus, and notice our x's are going to cancel there, and we get we're left with 3 times 6, which is 18. On the other side, notice our 3's are going to cancel, and 1 times x is x. Now we can simplify the 15 minus 18, and we're done. And notice x equals 0 was our restricted value, and that's not what we got. So we've got a perfectly good answer. All right, let's move on to example 4. So here our LCD is going to, let's see, for 8 and 4, the LCD is going to be 8. You may recognize we've already found some of these LCDs. So 8 is the LCD of the numbers, and we also need to include our x factor, our algebraic factor. And notice again, x can't be 0. Let's multiply every term by 8x. So notice the x's are going to cancel. In the first multiplication, you're left with 8 times 1, which is 8. And then on the other side, 8x times 1 over x, the 8's are going to cancel. We're left with 1 times x, or just x. Don't forget your minus in the middle here. 8 over 4 is actually 2, because 8 divided 4 is 2. It's just like simplifying the fraction 8/4, which is 2. That's all we're doing there. And then we have 2 left over times 3, so it's going to be minus 6 here. And I'm sorry, and we also need the x because the x did not cancel. So it was 2 times x times 3, which is 6x. So in this equation, notice there's nothing to simplify, but we do have some like terms. So basically we're going to add a 1 and a negative 6. We're going to get negative 5x there. And of course on the other side we have 8. And we need to divide each side by negative 5. So we're going to get negative 8/5, and that's not a restricted value, so that's a perfectly good answer. All right, let's move on. So here our LCD is going to include the 5 and the x, so it's going to be 5x. And again, x can't be 0 in either of those denominators, or we'd be undefined. So that's a restricted value. Let's go ahead and multiply all of our terms by 5x. In the first multiplication, the x's are going to cancel, and you're left with 5 times 4, which is 20. Notice the 5x's are going to cancel next, and we're left with just the 2. You could think of that as 1 times 2. 5x over 5x is just 1, and 1 times 2 is 2. On the other side, you get negative 15x. So let's add our 2 and 20 together. We get 22. And on the other side, we still have negative 15x. We're going to have to divide by negative 15 on both sides. And so we're going to get negative 22 over 15. And again, the restricted value is 0, and we're okay there. On number 6, see if you can figure out, well actually we did this earlier. Again, the LCD here, you're going to have to take the 18, because 18 is divisible by all the other numbers. That will be my LCD of the numbers. And we also need to include an x. So 18x is our LCD. Notice that x can't be 0 here. Notice 2 times 0, 0, 5 over 0 will be undefined. So again, 0 is our restricted value. Let's multiply everything by 18x. So 18 over 2, that's going to be 9. And the x's cancel here. So we're left with 9 times 5, which is 45. And minus 18 over 9, that's going to be 2. Notice the x doesn't cancel here. We have 2 times x times 8, so 16x. On the other side, the 18s are going to cancel there. We're left with 1 times x, or just x, minus. And then notice 18 over 3, 18 divided 3 is 6. And notice the x's are going to cancel here. You're left with 1 times 6. So here's an equation where we're simplified, but we do have x on both sides. So let's go ahead and get rid of the x on the right by subtracting x on both sides. And notice you are adding negative 16 and negative 1 there to get the negative 17. Let's get rid of that 45 by subtracting 45 on both sides. We get negative 17x is equal to negative 51. And if we divide both sides by negative 17, we're going to get 3. And again, that's a good value. For all the problems we're doing, we're not going to end up throwing out any numbers. But later on in this course, we'll run into problems where we will. Let's look at the next example. So here our LCD is just going to be x plus 4. That is my only denominator. Now notice what x can't be here. 0 is okay, because if you put a 0 in the denominator, 0 plus 4 is 4. So is there a value of x that would cause your denominator to be 0? Well, think about how opposites add up to 0. So negative 4 plus 4, that would be a problem. So here x can't be negative 4. That would make my denominator 0. Doesn't matter what the numerator is. If my denominator is 0, I'm undefined. So let's multiply each of our terms by x plus 4. So on the left, notice our x plus 4s are going to cancel. We're left with 5x. On the right, the first fraction there, the x plus 4s are going to cancel. And we're left with 2. Now be careful on the other. It's minus 3 times the LCD, which is a binomial. You do need the parentheses there. So you are going to end up distributing a negative. You could do it right there. I'm going to go ahead and do it in a separate step. So notice a minus 3 times x is a minus 3x, and a minus 3 times 4 is a minus 12. And we do have some like terms here, so let's take care of that. We do have x on both sides, so let's add 3x to both sides. We're going to get 8x is equal to negative 10. So let's divide each side by 8. And we're going to get negative 10/8, which reduces to negative 5/4. Just divide the numerator and denominator by 2. Let's move on to our next example. So here's the example where we have two different algebraic factors. The only thing I can do with them is multiply them. So that's what I'm going to do here. Notice what x can't be. In this problem, you might try to figure it out and then look at what I got. It's going to be negative 1 and 3 that are the problems, because negative 1 will make the fraction on the left have a denominator of 0, and 3 would cause the fraction on the right to have a denominator of 0. So these are values we could never have as solutions. They would cause one of the fractions to be undefined. All right, so let's multiply each side by our LCD. And notice on the left side, the x plus 1s are going to cancel, and you're left with 7 times x minus 3. And on the right, the x minus 3s are going to cancel, and you're left with 5 times x plus 1. So we have some distributing to do here. So you get 7x minus 21 on the left, and on the right you're going to get 5x plus 5. Everything here is now simplified. We need to get x on one side only, so let's get rid of that 5x. Get 2x minus 21 equals 4. And let's add 21 to both sides. We get 2x is equal to 26. And you can see 2 times 13 would be 26. And this is a good solution. All right, we have one last problem. If you want, you might try doing this one on your own and then checking your answer. All right, so LCD is 5 times y plus 2. We have a numerical factor of 5 and an algebraic factor of y plus 2. All I can do is multiply them together. So let's multiply, restricted value here is negative 2, because negative 2 plus 2 in the left fraction would cause our denominator to be 0. Let's go ahead and multiply both sides by our LCD. And notice the y plus 2s are going to cancel on the left, and you've got 5 times y minus 2. And on the right, the 5s are going to cancel, and you're left with 3 times y plus 2. So we're going to end up with 5y minus 10 on the left when we distribute. On the right, 3y plus 6. We're all simplified. We just need to get y on one side only, so let's get rid of the y on the right by subtracting 3y. Get 2y minus 10 is 6. We'll add 10 to both sides and divide by 2, and we're going to get 8. And that's the end of this video.